This topic is specificity and sensitivity of screening test. So first let's see what are screening test and how is it applied, right? So suppose this is a normal individual. Now suppose this is the time where he develops cancer without symptoms, and this is the time where he develops cancer with symptoms. Now this is the timeline or time chart. So this is the time where the disease actually develops, but this is the time where the symptoms of the disease appear. So where should we apply our screening test? That is in between these two times, right? So here we applied the screening test so that we can detect the disease even when the symptoms have not appeared, right? So it will give us why do we apply screening test? So that it gives us a lead time. So what is lead time? That lead time is actually the time between where the time when the screening test are applied and usual time of appearance of the symptoms of the disease. But here, as we apply the screening test, we get to detect the disease beforehand, and so we can delay the death or the fatality of the disease, right? So this is the use of our screening test, and this is the time where we are using the screening test. Now let's see the difference between the diagnostic test and the screening test. So screening test will be applied to those who are apparently healthy or asymptomatic, and diagnostic tests are applied where the symptoms or signs have already started to appear, or those who have the suggestive signs and symptoms. Screening test will be applied to a group of individuals, whereas diagnostic tests are usually applied to the single person. And here the screening test won't be that much accurate, that is, it is less accurate and should be less expensive, whereas diagnostic tests are more accurate and more expensive. Now let's see screening test sensitivity, specificity, and positive predictive value and negative predictive value. So before that, we classify, suppose this is our screening test results. So this we classify as test positive and test negative, and this is the diagnosis, that is diagnosis by gold standard test. So here we divide as diseased and non-diseased. So our data will be divided into 4 quadrants, right? So those who are diseased and came positive in the screening test also, so that is known as test positive and disease. So we mark as true positive, that is true positive. Now suppose there is a group that is diseased, but those who came negative in screening test, that is classified as false negative, that is it came as falsely negative, right? Now suppose this is a group of non-diseased. So non-diseased, but it came as positive in the screening test, so it will be false positive, that is classified as group B. Now group D is those who are not diseased and came negative in our screening test, so those will be true negative, right? So these two are true, whereas these two are false, right? False positive and false negative. Hope you understand this concept. So let's revise this once more, okay? Suppose this is our disease group or disorder group. This is no disorder, right? This is positive test result in screening test, and this is negative test result in screening test. So this was our A group. A group is true positive. Now B group is false positive, that is which came positive in result but has no disorder. And this is C group. C group is false negative, that is they have disorder but they came negative in our screening test, that is false negative. And true negative is our group D, that is they have no disorder and came negative in the test result. So there is a true negative, that is our group D. Now let's see how to calculate sensitivity specificity. Sensitivity means ability of the test to detect true positive out of the total diseased, right? True positive out of total disease, that is true positive divided by true positive plus false negative into 100. Now let's see in the chart once. See, suppose true positive out of total disease, so this is our disease group, right? This is our disease group. So true positive plus false negative, true positive plus false negative is our total disease. Out of that, true positive should be into 100 should be our sensitivity. Now how to calculate specificity? Specificity is the ability to detect true negative out of total non-disease. So which one was non-disease population? This one, right? So false positive plus true negative. So false positive plus true negative is our total non-diseased. So true negative out of total non-diseased into 100 depicts our specificity. Now there is two other concept, that is positive predictive value and negative predictive value. Positive predictive value means the ability of the test to detect true positive out of total test positive, that is true positive divided by true positive plus false positive. Let's see in the chart. This is our test positive is this one, right? So true positive plus false positive. So see here, true positive out of total test positive, true positive divided by true positive plus false positive into 100 depicts our positive predictive value. Now what is negative predictive value? That is our true negative out of total test negative, right? So this was our test negative, that is false negative and true negative. So true negative out of total true negative plus false negative is our negative predictive value, right? So here is another mnemonic how to remember sensitivity, what calculates sensitivity and what calculates specificity. So in sensitivity, remember this, no problem, right? This is our mnemonic, no problem. So NP, N is for P and here P is for N. So in specificity we calculate true negative, in sensitivity we calculate true positive. So remember the mnemonic, no problem, right? So now remember another thing, that is sensitivity is the most important criteria for a good screening test. So for good screening test is sensitivity, and for confirmatory test, that is more diagnostic test, that is specificity. So C for specific and S for screening, sensitivity for screening, right? Now let's see another concept, that if our cutoff is raised, so what will happen to the screening test? Okay, so suppose, see this chart, this depicts the non-diabetic population, that is a non-disordered population, and this is the diabetic population, that is the disordered population. Now suppose we apply a cutoff here for the screening test. So these are the population of true negative, these are the population of false positive, that is here if we mark the cutoff, this will come this is coming beyond this point, so this will come as false positive in our test, that is non-diabetic but it's coming positive. Now this population will be our false negative, that is below the cutoff but it is a diabetic population, and this will be our true positive. Okay, so this was the picture when the cutoff was around 126, suppose. Okay, now suppose if we increase the cutoff, what will be the impact on our screening test? Suppose we increase to 140. So now this is the benchmark, right? Now this is the benchmark. What happens is true false negative increases and false positive decreases. Let's see how. See, this point is going over here, right? So this part is increasing and this part is decreasing. This part will decrease and this part will expand, that is increasing. So false negative will increase and false positive will decrease. So what will happen to sensitivity and specificity? Sensitivity has true positive by true positive plus false negative. So false negative is increasing, that is the denominator is increasing, so sensitivity will be decreasing. So opposite will happen in case of specificity, that is it will increase. If the cutoff is increased, the specificity will be increased. Now what happens to the positive predictive value? Positive predictive value means true test positive, that is true positive by true positive plus false positive. And what happens? False positive is decreasing, therefore the denominator is becoming lesser, so this will increase. Positive predictive value will increase. So opposite will happen in case of negative predictive value. So this will be the effect of cutoff increased in case of screening test. So let's see it again. So this will be the picture. So suppose the cutoff is increased, this will be the effect, that is our specificity will increase, our positive predictive value will increase, and sensitivity will decrease and negative predictive value will decrease. Whereas lowering the cutoff will lead to the opposite effect. You can see it in this box, right? So this is the effect of the cutoff value increase or decrease. I hope you understood the concept. So this is it for today.
Thank you for watching. I hope you found this video helpful. Do like, share and subscribe to this channel to get more videos of this kind.